Alright, let's look at our sound here. Looks like sound is good. Looks like some of our other stuff is good. Alright, so what do we got going on here tonight? Let's turn on our little Go Rotate, see what's going on over there. And let me transition over here so you guys can see what's going on my stream. I am going live tonight because I'm not going to be able to tomorrow night and probably not Saturday either. I'm going down to Tucson to see one of our other members from the Professional Linux Users Group, and I'm going to go hang out with him. He's having a baby shower, so we both got invited, me and the wife. Plus, it's a bit of a drive. It's about 2.5, 3 hours down there. So we're going to drive down there, and then that'll be on Saturday. But tomorrow night I can't stream because I have a friend fighting in Thailand. They're fighting for the what is that, PFL or whatever that fight league is that's going to be on Amazon tomorrow night. One of my friends is fighting in it, so we're going to watch that. And me and some of the guys are going to get together here and watch one of the people that we train with go and fight. So that'll be kind of cool. Actually, two people that I've trained with in the last year are fighting on that card. So we'd look that up if you guys want. But like if anybody's interested in watching that, just let me know. I'll tell you all about it. What were we looking at here? Me and my college students were going over, I'm in a course, or I'm teaching a course on privacy and data security. And then it's actually kind of funny. I was looking at my new college class that I'm in, and I was realizing that the one that closed out like 2 weeks ago had no grades still. Like some of the grades weren't graded. So I sent a message to the I guess he's like the dean over all of the chairs. He's like the head of the chairs for all the people that, you get a chair when you're working on a dissertation. And he goes, Scott, I don't have you assigned to any chairs. Who have you been working with? And I go, well, not really anybody. I've just been kind of doing the courses and turning stuff in, but nobody's been grading it. And he's like, oh, well, we need to get that fixed then. So we went and graded it all and stuff. And apparently I had an F. I didn't even know I had an F because I had already started the new course. But he moved it to an A, which is what was the correct assessment because I had done all the work. So that was good. Yeah, but what are we working on? I'm kind of catching up on stuff. So I'm looking at the rotator over here and seeing what we've been talking about in these different weeks. And I thought I'd do something kind of fun. I'm not going to change the title here, but if any of you guys want to kind of just see like a quick run through of my werewolf presentation that I'm going to be doing for work, I'm going to do it. I've done it once for the prologue, but I've added to it since then. Plus, I'm going to kind of flip over and do a few demos. So if you guys wanted to see what happened over here, no, don't worry about that. I don't want to fork that or any of that. Is the Go Rotate still working? We can close these ones down. Start back over here. Here we go. I do need to work on the course outline a little bit. I need to. We're getting to. Shoot, I don't have nearly as much time before the course is going, so I need to start getting these things knocked out and getting more of my explore, practice, apply put in there. And then I need to split out the different stuff. And also, I feel a little bad. I think yesterday, right as we were finishing up stream, Blaze must have raided me right as I was raiding out, because I saw him. I was going to raid him, and apparently he was going offline and raided me, so I missed it. So I have to, if I see him, I'll have to apologize. I don't like leaving. And I think did I raid out last night? I think I did raid out over to Running Man. So I think maybe everybody just went over there with me. I don't know. But what else? I'll put a thing over on the Twitch side. I'll say here, you can decide. Where is a poll? I gotta put it together as a poll. And I'll say, and I'll also take into account what you guys say over on the YouTube side. But the question will be, what do we talk about werewolf? Yes, no. I'll give you guys 5 minutes. 5 minutes to decide that. Do we talk about werewolf or no? And if you guys say no, that's fine. I'll just kind of keep working on what I'm working on. If you guys say yes, then we'll do that. Wrong course. Good gosh. Here's our operations for the lab. Okay. Let's go check some things in our environment, make sure stuff is working the way that we expect. We can go here. Just bang 748. Hitting uptime real quick against all the nodes. Make sure that all the nodes are up. And I did not reboot them the last time I did maintenance, so that's also a thing to think about in the lab context there as well. Let's see, what else? Got the courses. People are working on the books still. Made sure our Prometheus was working, so we don't need that right now. Make sure the labs look good here. This is kind of our little heads-up display for labs. Should be able to see all the servers there. We can also organize them by host name. See that all 15 of them are there, which it looks like they are. That's good. I do have a thing I really need to get done in the environment, and it is over here. We need to make sure that we have the capacity for the target boxes. So let's look at the memory on these. This is not going to be where we're going to put it. Let's check this guy out. Why is he not connected? What's his capacity? All right, this is probably where we're going to put the target boxes then, which will be good because then the target nodes will be separate from the target, the auto nodes will be separate from the target nodes, and that'll be good. All right, so what I'm gonna do for this, I've got the Rocky template here, but the Rocky template, oh, here's a target server template actually. Let's look at his memory and his storage. Okay, so we do have the target server template. All right. I forgot that we had gone this far and done all this. All right, let's delete him. I forgot we did all that. This is why you guys got to keep me honest. Okay, and I got the UUID for that as well, don't I? Target server template. Where's his UUID? 6987, 697. Yeah, so that's right. And then we did this. We're going to loop over nodes. So then, yeah, we just got to give them names and then we can run it. So, all right. So we're going to give them, oh, host. Which host is he going to be on? We're going to put him here. And his networking is 202. So the host here will be 202. Okay. And the way we're going to do it is we're going to call it target. Let's do. I'm trying to think of the best way to do this. Let's call it target 11. Think about this. We'll say Y for Y. I'll do P, and then we're going to do target 1, 2, and it will be a MAC 2. Let's think about this. How do we want to name these? Because we are, I want it to be obvious that we're going to, because that looks like 11 and 12 obviously, right? And I would like it to be obvious that you're going to the target for your auto server. So like auto 1 will go to target 1. I guess we could do A and 1 B. I looked like we only had one vote for yes, didn't have any votes for no. We'll talk werewolf here then. We'll do a little bit of werewolf here in a second. I'll run you guys through what my presentation is going to look like. I'll practice it a little bit. That'll be good. What do you think about this? You might say, well, the host IP is the same. Yeah, the host is always the same because we're hitting the host server to deploy the node. So that's going to stay the same. But we need to get this name. Guys, naming is like the worst for me. I'm terrible at names. So we could do 1A and 1B, but those are just terrible names for servers. So I don't like putting dots in names because then when you get into like fully qualified domains, that starts getting weird. So I don't like that. I guess we can do 1 dash. It's not gonna be super pretty either way. But now let's take this and let's say y8y, and we can actually we'll hit P right here, and then now we're gonna change this to 2 and 2, and this is gonna have to change to, let's make this 1 1 and 1 2 and 2 1 and 2 2, because our max have to be unique because I'm actually taking the max. So let's say y8y. Whoops. I think you can just do 8y, but y assigns it to the y name. Anyways, we'll change this to 3 1, 3 1, and 3 2, 3 2, and then we'll hit P, and we'll do 4 2. And then, yep, and then we only got to do it one more time, so we'll hit P to paste it again. It'll be 5 2, or 5 1, and 5 1, and 5 2, and 5 2. Now the max aren't nearly as important, but that's fine for this. All right, so let's go here. Let's make sure our target deployer has the things that we need. It's gonna grab in. It's gonna pull these in as the MAC, and then it's gonna do the individual node MAC at the end. So it's we're only changing the last 2 hex. Those are hex numbers for MAC at the end there. This should work. Let's go look at our deploy. I don't know last time I've run a deployer like this. Yeah, we'll be fine. All right, we're gonna need, in this environment, we've also got a vault, so we're gonna need to know the key. So Ansible, let's see if it's hidden. I don't have a hidden key, so I'm just gonna need to do the key. Ask vault pass, right? We got to ask for the vault password. Move this out of the way here. We're probably good on that. Pattern matching stuff, probably don't need it anymore. Probably don't need the Loki stuff. Probably don't need that. Got the book. Okay, good. Let's do this. Ask vault pass target deployer .yaml. Let's see how this breaks, because I want to see what it's running. Should ask me for the vault password. It's always the same. I hope it's always the same. Oh well, that would help if I would name files right. Let's just do this. Really? Come on. There we go. You don't have to put in a password if you don't want to. You can also go and put that file in. We watch these deploy. If they work, if they break all over the place, we'll see them break all over the place too. But we should see these deploy right here as the... Yeah. So debugged what it's going to do. Target 1 1 1 2 1 3, and then if it works, we're going to see them deploy right here on this box. So they'll be target, so they'll be after the Rocky but before the werewolf. So where was I at here? Oh, we were going to do werewolf. We will look at werewolf. We'll do the presentation here in a little bit. I'll talk through it and just let you guys know what I'm like it's the same thing that I'm going to show my company, except in my company's one, the one that I'm doing for ProLug is slightly different because in the company one, I'm going to name the customers and things that we're actually doing. I won't do that in the one that's outside. Share the history on Discord. Lord Processor, you said, can you please share the history on Discord? Like my history of all those things? Like commands that I've done, all these? Yeah, I mean, it only makes sense, like, in my context of my environment. But yeah, I should show. Oh, look, here's target 1-1 standing up. We're going to see all of them deploy. So I've told you guys, like, Ansible, and this is one of the reasons I picked XCPNG in my environment originally, is I can deploy things, but it's not... It's like XCPNG doesn't have a Terraform. I would prefer to do this type of work with Terraform, but there's no Terraform provider for this. It's so old, and XCPNG is not really there. I'm pretty sure if I was running Proxmox, I'd be able to do it, or if I was just doing this directly in like a what's that? Not libvirt, but was it QEMU or whatever that environment is that people stand up on just regular Red Hat boxes. But this works enough for me. Once I get these up, let's go check real quick. I want to check them. They're going to come up kind of slow. We didn't do them all at once. We did them one at a time. Let's check his networking. And he did get that MAC address, the BBDAFF1. So we will end up putting that into our template. We can either create them programmatically on the Werewolf node and just assign them and add them to the nodes config, or we can just go plop them down in there and change the things each time. Smitty, you said the Proxmox ones are pretty, or they're not official, but they work. Nice, yeah. Well, and you're always going to have some problems with that. I mean, this is one of these things like we were talking about adopting open source in the community and adopting open source like in the world. One of the things you pay a little bit for in that context is that, well, if it's not supported, it's not supported. In fact, that's a showstopper on government things. I tell you guys often, like in the professional world, it has to be something that's tenable to the security posture of your organization. And you say, really, my security posture? Yeah, not being able to overcome some type of like security vulnerability, or not being able to overcome some type of maybe downtime or denial of service or any vulnerability in a system makes it, in a lot of organizations, something that's no longer able to be used, no longer able to be productionalized, and it goes against what we call like our risk management frameworks, right? Like it's too much. Oh yeah, Lord Processor, I don't have anything in there that's not. Yeah, I don't have anything in there that you couldn't see. Yeah, hold on a second. Let's go. I'm on this one. Yeah, well, this is even a different one, but this is all the stuff like in my home lab. All my Ansible, old Ansible commands. Yeah. Yeah, I'll grab all that if you want. Yeah. By the way, good time while those things are creating and kind of going slow. To tell you guys, we do have a Discord. You know, you guys can go in there and check on stuff. In this case, here's Ansible commands. It's so long that it's just going to be its own thing. But yeah, there you go. And if anybody wants to look at that or download it, they can. Those are just old commands I was doing in my home lab. Let's get that out of the way. Those are building. You're seeing them build target 1-1, target 1-2, target 2-1, target 2-2, and those names, since they're going to be added to the Werewolf cluster, they will be added to the host file, so nodes will be able to get to them directly. And when we start the automation course and there comes some time to need to configure nodes, you're going to be able to do it off of the auto systems. The auto systems will be able to get into those nodes. And I haven't decided. So I had kind of thought about it, and I was like, well, I could just have auto 1 only be able to get into target 1 and target 2, or target 1-1 and target 1-2, so nobody can mess with each other. But then I got to think about it, and I'm like, well, I could just deploy them all with the same key, but it's really actually not that much, not that difficult to change the key. So I might just make an overlay for each and then just allow that. So anyways, we could do that different ways if that works. But That's something, man. I gotta stop talking about and start actually doing it. All right, this is still running. I should have timed this to see how long it takes to deploy these nodes. But yeah, these nodes are standing up in the environment. We don't have to, like, I don't have to go auto, like, I don't have to go do each one manually. I can just talk to you guys while they're deploying in the environment. And when I'm done, if I wanted to, I can tear these nodes down automatically. I have a destroyer in this environment too that destroys any nodes that I want as well. I thought it was built into this, but looking at that, it's not in there. So I have it in one of my folders somewhere. But it's basically this same command that you use to create these. It's like an absent, and it'll delete virtual machines if you want as well. You might ask in our cluster, how do you just deploy and destroy things and with no regard for the nodes? Well, the nodes are stateless, so if you ever want something in our home lab environment or in the ProLug lab environment to be persistent, you need to store it off in like the work directories, which again, I got to write up. I was talking about, it's one of my things over here that I have kind of as my to-dos. I need to write up a frequently asked questions for the lab. Like, so it's almost like a lab guide. If you're going to connect to our system and you've got access and you've put your key up in the Discord, right? You put your public key that I can go and add to our authorized host files, and you can connect into our environment. Well, now what? Well, there's obviously the courses, but also there's things that you could write your own stuff in there. You can go work on your own stuff in there, right? The acceptable use policy of the labs and like the message of the day is really do whatever Linux system stuff that you want, within the confines of trying to get better at doing this stuff. Being able to connect to servers and push and pull data, that's tremendously important, right? That's tremendously useful. Anyways, real quick in the Discord again. There are events coming up. There's the Bash study group on Saturday morning and then Saturday night. So we have those spread out throughout the day so people can get in there, whether they're on this side of the globe or the other. Down here, late night Bash study. Yep. We do our maintenance on Sundays. Also, part of this will probably start out as maintenance, and then that's going to roll over into my study time because Sunday nights are when I do my research work, right? If I'm not writing heavily during the week, Sunday night is my finish up everything for the week and do all that. So there will be some of that, and we'll do maintenance, and then I'll roll into doing that stuff. So people that want to do like academic stuff. In fact, that's actually what I have in the title today. I was going to do that today. And then on the 13th, Saturday, September 13th at 3 p.m., but it'll be different in your time zone most likely, so go check in the Discord. People that have done the admin or the security courses before and done the final projects, not everybody got to present, so I'm giving them an opportunity to present if they want to practice talking through, if they want to show the community what they built. A lot of people have done some really cool projects, and also if any of the older people that have already done it in previous runs want to do it again, they can come and talk through and that stuff. I'm allocating about 20 minutes each, so if we have 6 or less people, it'll only be 2 hours, right? That's as far as it would go. If it's only, I think I have like 3 people that said for sure they want to do it, so that's at least an hour worth of talks. But it's good for people, right? It's good if you're going to have to go sit in an interview and explain yourself to somebody and explain why you're the right person to be put in charge of running this Linux system or set of Linux systems that people have. Well, one of the ways you're going to prove it is by having built Linux systems and operated and maintained Linux systems, right? So that kind of that idea is that's important. All right, then there's the writers room, and this is kind of one of these places I always tell you guys, this is a place to get involved and hang out with other people that are doing stuff in the community. I don't run this, the guys run this. And then we're going to start on September 20th. We're going to start the security engineering course round 2 for people that want to do that, and we're going to start the 16-week automation course. This will be the first run through of this course, and we'll get that going as well for people that want to just start doing automation, building an automation mindset, thinking about how to make yourself still valuable to the industry. That I know a lot of people are super worried about AI taking all the jobs and stuff, but there's still things that I see that have to be manually done. So there's that. All right. Anyway, so let's you guys voted a little while ago. My servers are still building. It's going to take a little while. They're all building over here, the target servers. You guys see the playbook running here. We can wait until that's done. or we can just start talking werewolf, right? Um, there we go. YouTube, the student investor. Why I tuned in late. Is this sort of like a presentation, sort of mock interview where I can gain some valuable insight? No, what I'm doing right now is just kind of hanging out in the home lab and putting stuff together. I am deploying nodes that are going to be the target nodes in our automation course in a couple of weeks. The only thing that you missed was we had a vote earlier, and the guys said they wanted to talk through my werewolf presentation that I'm doing for work. So we do like these brown bags at work, and I'm doing one for September, and I want to say it's like, I think it's the week of the 16th, like the 16th and the 18th or something is when I'm doing the presentation. But I'm doing a version of it that I prepared outside of work, and then I'm going to clean this up and change it a little bit and turn it into a presentation for work. Because I use Werewolf professionally all day, every day at work for big high performance compute stuff. But what I'm going to show you guys outside of there is how I use it at home in the home lab. So actually, we could start that while that's building. So we're pretty confident that these nodes are all going to build. Look, we see them all building. I say nodes, but I could be talking about servers or targets or whatever. These are little boxes. These things are so small, and we really are going to abuse these poor little guys. They also are coming up with no. Let's go look at the console. They shouldn't have a network. They shouldn't have anything on them, right? Well, if they start, what's going on here, console? Console should go dark. Yeah, we'll leave them on. But also we can see up here the capacity of our environment. Yeah, we're using, these are very small nodes, so they're not going to push things up too much. As far as the overall usage and storage, they're not using too much storage either. Okay, let's get that out of the way. Let's go talk werewolf a little bit. So, this is me. People that don't know me, I don't care if people know who I am on the internet. I'm a real person. You can look me up. And I'm giving this talk to you guys in the professional Linux users group, and I guess online as well, about how Werewolf fits into high performance and supercomputing environments. So that's what I've been doing for the better part of the last 20 something years, is Linux systems administration and Linux systems engineering. But I also have kind of gotten my career the last 15 or so years in high performance compute. And high performance compute is defined a very specific way. I'm going to show you the NIST standard for that, and what Werewolf does and how it kind of applies to that, if that works for you guys. Console is cooked. Oh, that console is definitely cooked. Yeah. I don't know why. I mean, I was just wanting to see. Yeah, see, now he doesn't have, he's not configured yet, and that's fine. We'll give him a configuration in Werewolf, but all the nodes are trying to do DHCP, and they are all coming up with, again, nothing. So let's talk about what Werewolf is doing in an environment, and we can actually look back at those nodes here in a little bit and kind of see that. So if you've never seen Werewolf, I know it's not spelled right, but that's the way that they spell it. Let's get into it a little bit. So overview, what do we do around here? We're going to talk about this in the context of the Professional Linux Users Group, which is a group that I run with the standard goal of trying to get you guys doing this stuff professionally. If you watched me for more than 5 minutes and haven't given up on me, it's probably because you're like, well, I like doing Linux at least as a hobbyist. But if we want to get over into the professional space, that's what our group kind of tries to get you to do, is like codify this down into like rules and procedures and policies that you can understand and how to go do this for a company. All right, then we'll talk about why are we talking about Werewolf, what is a supercomputing or HPC system, how does Werewolf, or what does Werewolf do, and how does it do it in relation to the problems of supercomputing. So that's kind of what I'm doing here. This is kind of my talk, right? High level overview. I think I have some things to slide in here, but we're just kind of running through it real quick. So what do we do around here? Prolog, we teach people Linux jobs, and sometimes we use HPC or supercomputers to do it. The environments that I build are the same types of environments that I build for high performance compute. I just have a lot less compute in the home lab. I only have 4 machines. I don't have a back-end high-speed network. I don't have high-speed storage, those kind of things that tend to be part of a high-performance compute system. I have a different talk on YouTube about like what it means to be a high performance compute engineer if you already have a background in Linux. And I think that's about a 2.5 hour presentation. And I am going to redo that one eventually. But for now, this is what we're talking about. And we're going to talk to a very specific component of HPCs, which is the inventory management and kind of configuration part. So, all right. So what are supercomputers, or alternatively, like how do we build them, right? Well, they're generally comprised of these components. And this reference model comes from the NIST, which is the National Institute of Standards and Technologies, 800-223 PDF. You can go download it. You can go download it right now if you wanted. And this is kind of what an air-gapped high-performance compute network looks like. And you say, well, why is it defined as air-gapped? Well, because from that firewall there, they've got a cluster external network that you can only get into the back-end cluster through that access zone. That access zone is its own network. It's got login nodes, data transfer nodes, and web portal nodes. You can log into the login nodes. And I would liken that access node or that access zone a lot like if you guys have ever seen a movie, or if you've ever like been to a subway where you go down into the subway and there's like all the terminals and little kiosks and things that you can do in there, or however you want to look at that. And login nodes are how we log in and do user management typically. A lot of times those are bastioned environments where once you come in, maybe we even have bastions before the login nodes, where then once you get into those login nodes, you can start to submit jobs into the cluster. The data transfer nodes are where we move data into and out of. So if you have a big work set, you would come in on the login nodes, maybe move over to a data transfer node, pull down the data. I mean, we're talking sometimes petabytes and exabytes of data. So people are pulling down data over these high-speed networks and staging them from the data transfer nodes down into our back-end storage nodes. Then they're ready to be used against the compute nodes in the environment. Real quick, backing up and level setting for a second. Probably everybody here has used some type of virtualization, right? You've got one physical box, kind of like this. Where's he at? I've got one physical box here called XCP-NG Big New, and he's got a bunch of virtual machines carved out of him, right? High-performance compute systems are almost exactly the opposite, in that we come in as a user through these login nodes, and we don't interact directly with the individual compute nodes. We submit jobs through a scheduler, right? A scheduler like a Slurm or PBS Pro or Platform LSF is a common one from IBM. And we schedule jobs, and those jobs run on tens or thousands or tens of thousands of nodes in some cases to crunch numbers and do big data. Weather, I work for NOAA, and this is what our supercomputers do for weather. 2,600 nodes on the back end, and people submit jobs and they run. Or we have the normal NOAA workflows for the climate prediction and those kind of things that run every 6 hours all the time and feed all the weather stations and all that kind of stuff, right? My point in showing you all this is this is a big high-performance compute thing. This has been around, this model has been around for 30 years, right? This is what we do. But down here, cluster services and provisioning servers are a thing that we have that are not very modernized. I mean, we've got XCAT. XCAT's been around a long time. IBM just dropped support for that last year. We've got some other provisioning and cluster type services, but what are cluster services? They're going to do like an inventory of all your nodes. They're going to probably be able to reach all the nodes. They're going to keep the images and the repositories and all these things off to the side of the big supercomputer that's kind of sitting over here. Because for all intents and purposes, this is the supercomputer, the compute nodes and the storage with their back-end networks. And then the scheduler is telling them what to do, but these nodes are then communicating directly with the storage nodes. And we're not getting into it too much, but the storage nodes can be Lustre. Lustre is a very common one. GPFS. Weka is kind of an up-and-coming guy. And what's this other one we're using now? I cannot think of the name of it. Hitachi used to be real big in this space as well. But what's that other one that's kind of big and it uses like AI to deduplicate data and stuff? What is that name? It's I'll think about it, and then if I come up with it, it's not really germane to the conversation. We don't really care too much about it. But supercomputers look like this, And then what are some major problems with building and operating supercomputers, right? Like, so if we're in the business of like building out supercomputers, we might want to think about what kind of happens. Well, there's a lot of modernization problems. Like, we're used to each of these big compute nodes over here being what we call a stateful node, or sometimes we call them diskful nodes. And what that means is if the node goes down and it comes back up, all the changes that were previously applied are still there. And you might say, well, that sounds wonderful to me. If I make changes in my environment, I want them to be tracked against all the nodes. And I say, well, that's cool. Okay. And you probably did it through Ansible and you were very smart about it and stuff. But what if like 17 nodes over here were down? Well, when they come back up, they need to get all those changes that you did for whatever amount of time they were down. So now you got to keep track of changes, put it probably back into a build book for when nodes come back up. And there's just a lot of like kind of nightmares to that. Patching and getting downtime for stateful nodes can be difficult at scale. You know, I have to get a time where I can take these nodes down, even if I roll through them. It's just, it starts to really be a problem. Stateful nodes also do not adhere to CI/CD best practices, which is continuous integration and continuous delivery best practices, because again, you're doing one-off changes on them all the time. Somebody comes to you with a question, or somebody comes to you with a ticket, and you change it on some of the servers. Those servers are now what we call snowflakes. They are different than all the other servers. Snowflake in this concept means like the idea that they are unique, right? Unique snowflakes all over your environment. And that's a terrible thing to try to maintain. So changes across the environment are hard to track and replicate in redeployed nodes. So one of these nodes has been up 3 years, and he has to go down and get disks replaced because something's bad, or pull out a motherboard, put a new one in. You have to just re-image the disks back to the old image from 3 years ago. Now you have to run that playbook, whatever you have, hopefully you've kept track of it, and replicate all the changes over 3 years in that environment. That's a nightmare, guys. That's like I could literally have nightmares about that, right? So we need a better way to do it that's not stateful. And we've had stateless nodes for a long time. What a stateless node does is it goes down, comes back up, doesn't know who it is, checks in with the cluster services and the provisioning server, and becomes a new node every time. Now that does adhere to CI/CD best practices, because that node's always going to be whatever the updated image is and whatever you baked into all the most recent changes. So then there you go. Nice snowflake servers fired, no doubt. Yeah. All right, so let's talk about a little bit about Werewolf, this tool that I'm kind of mentioning. You know, I'm going to change something here real quick, because that is like, let me move you guys like, put you guys over here. There. Chat can be over there, and then chat won't probably be hit as hard by the different colors of things, right? All right, right, because like all these things are over and we can't see what people are saying. But okay, it's developed and supported by CIQ. Now, if you say, hey, CIQ, that kind of sounds familiar, but I don't know where. They're the same guys that support Rocky. They're the same guys that forked Rocky from CentOS, so that's important. They have a fair amount of like support effort to maintain people that are still on CentOS for some amount of time. So they do that. There's a website, werewolf.org. There's a GitHub for it. You can just go download it. And in all the builds, they get an RPM installer for RHEL and Rocky systems. And then if you're on the SUSE or SLES systems, you get a zipper install, which I think is still, I forget what the extension is on that. Requires RHEL-based systems, but can maintain any of. Actually, this is not true. I need to edit that. It's RHEL or SLES, right? That's what it deploys to by default. And it does run as a standalone server within systemd on port 9873. So it is a systemd managed server running, or service running inside of your server, right? You get a PID for it, right? You get a process ID. You've got the things it's doing, and you can go and look and see that it's running on its open port. Cool. Now, Werewolf controls a bunch of other things. We're going to get to that, but just what Werewolf is at a high level is right here. Okay. So we come down here. How do we install it? Again, binary RPMs for RHEL and SUSE are available as part of their normal deployment process. You can do DNF install against the RPM, or zipper install against the SUSE RPM. Yeah, it's still RPM, but If you want to compile it yourself, you can. But source code is available with following dependencies. You need make. You always need make if you're going to compile code. And then you also need Go, right? So Go is part of it. And then there's runtime dependencies. So this is just build dependencies up here. There's runtime dependencies. If you're going to run Werewolf and make it work in an environment, you need to have a DHCP server present. You need a TFTP server present, and you need an NFS utils or NFS server running. So NFS utils is the RHEL equivalent, and then it's different environments will call these different things, but in the Red Hat side of things, it's going to be NFS-utils. All right, so this is what you need to kind of get Werewolf on your servers, right? So we talked about what it is, and then we talked about how to get it on your servers, but what is Werewolf doing? Like, Werewolf's just sitting here confused. My wife loves these pictures, by the way. She's over there shaking her head. It's like a little picture book. So here's a Werewolf. He's confused. He doesn't know who he's going to attack next. But how does Werewolf work as a cluster manager, right? And yeah, I'm going to leave these all in for my actual professional presentation because, you guys, I've been an engineer so long, I just don't care, right? As long as I'm not swearing in a presentation, I'm doing pretty good. Is it like a jail subsystem that requires 24/7 support? I don't know the context of that. I missed it, but that's that. All right. So Werewolf takes over an environment. Werewolf runs DHCP and assigns identities for iPXE boot. Right. Werewolf keeps an inventory of all the systems in the environment. Werewolf provisions servers out via TFTP and gives out appropriate components. It shares out NFS for NFS configurations. It controls all the cluster keys, so you don't have to do the key management for yourself if you don't want to. You can rotate keys very easily and just have Werewolf push it. And then control share users for the cluster if you want it to be your base of users, if you're not getting your users from like Active Directory or some kind of other type of thing like that. Real 10G or Real 10J, I'm not sure how to say that. I run this in my home lab. I run Werewolf right here. So we're going to see some of the things Werewolf does. Right, here's Werewolf running in my home lab. I have a full set of nodes that people can connect into, like this over here. Well, actually, where do I have it? Hold on. I think it was right here where I was. Yeah, so just jump into like the Prolog environment here. And then let me move this out of the way over here. Hold on. I actually found out earlier that I could roll through these. Oops. Grab this real quick. And where do I have? Oh shoot, I don't even know where this is anymore because I was doing this earlier and I moved everything around on accident. Oh yeah, I have no idea where this file is now. Give me 1 second. Ah, there it is, hold on. So, in my home lab environment, you jump in and you go to a Bastion node, and then now I have 10 seconds to choose. If I don't choose in time, I'm going to get kicked out forever. Well, not forever, but I'm going to go to one of the security nodes, which are the hammer boxes, and then if we do like a df-h, you can see the Werewolf server that's functioning as like an NFS. If we reboot this node, it's going to come back up clean. But we're going to get to all the stuff Werewolf does. I'm just answering somebody's question here, which was like, has anybody seen a use for it? Yeah, I use it in the home lab for the Professional Linux Users Group, and it works fine for me. Yeah, Kung Pao Jeff. I mean, we're all four hobbyists, right? I'm all four hobbyists hanging out. We do all the Linux we can, but I do also try to give you guys the ability to do this stuff professionally if it's, you know, not retirement, just hanging out. So what does Werewolf do? So Werewolf manages the entire environment, right? And what it does, it even says AI in the corner there. Werewolf manages the entire environment. So node definitions, we can customize each node with node definitions. I'll show you those. We can have DHCP settings all controlled by that. We can use IPMI connectors and turn things on and also console into servers over IPMI, which is super powerful. We can do image repositories, so I can download images from Werewolf, or I can build my own images. In fact, one of the things I was going to bake up here, if we do the security red team course and do all the red team stuff that I used to do, we will probably bake that up as a Kali image on top of using Werewolf. I just haven't gotten around to do it. And then system overlays and runtime overlays are things that happen kind of as a personalization to the server as it gets deployed. And then there's different kernels that we can run, but I don't run different kernels. I allow my image to control the kernel. But Werewolf kind of maintains all of these different things over here. Images, system overlays, runtime overlays, and kernels. Now, system overlays run as a one-shot as the server's deployed, and runtime overlays are updated by the cluster every configurable. It can be down to 30 seconds. It can be up to 10 minutes. I think you can go even in the hours if you wanted. But runtime overlays can update stuff like users and passwords and just all kinds of things if you want them to. So Werewolf manages this entire environment. So if Werewolf can do all those things, who controls Werewolf, right? That's the next question. And the answer is we control the tool. We control Werewolf. We make it do the things we want it to do. But how do we do that? What does that look like? Well, Werewolf has its own language we can interact with. This WWCTL, or some people I think call it WWCuddle. I think that's weird. I always think that's weird when people say cuddle there. I've always just said like WWCTL or whatever CTL type command, but okay. And when you do WWCTL, you have this usage that pops up, and there's all these different kind of subcomponent commands that we can do around all those things we just talked about. We can clean up, we can configure, we can do image operations and node operations and those kind of things. We can do power and overlay and just all these things. We can even SSH into our servers and do minimum type configurations of our stuff. So over here on the right, we can do an image list and see all of the images that are in our environment. And we can also look at them via like IP address. Now, if you want to see that live over here on my Werewolf server, I can go right here, WWCTL image list, and those are all the images. And then I might say node list. Here's all the nodes that are defined in my environment. And then I can add a -A, which is going to blow the screen up. That's a lot of information. This is the information for just the Rocky 5 server right here. But I could do something like this. Grep for just the IP header, right? And now I can see the IP address of all my machines. And I could make sure that that aligns with maybe my Etsy host file. And then, oh yeah, okay, so the servers that I expect to be there, Auto 1 through 5, Hammer 1 through 5, Rocky 1 through 5 are all there. Good. So this is like a Linux context of an Etsy host file, and that's also being maintained from the nodes file inside of Werewolf, right? So this tool like can kind of just be the foreman and do kind of everything in our environment for us, all right? We can directly interact with it via the YAML config. So we can go into like the nodes.conf file, and we could directly set up more nodes. So I just deployed a bunch of blank template nodes, which are called target 1-1 through target 5-2, right? 10 nodes that are going to be part of our automation environment, and they're going to be targets of the auto servers. And I could either add them as a WWCTL node create type command, or I can come in here, and if I already have a profile template built, I can just deploy the template as the target nodes right here. So it could be like target 1-1, profiles default. Do I want it to get the Hammer Linux config, or do the image, or do I want like what images? I have 3 images in my environment, and what do I want to use for that, right? Like what do I need as the underlying piece? Then there's also some network information that gets assigned to the node, and I can either populate that as I create the nodes if I use this, or I can have it already set and just lay it in as a template. So it really depends how I'm feeding data into Werewolf, like what type of templating I want to use. Do I want to go use some type of Jinja template and feed data in through like a CSV? Maybe somebody in the company has 5,000 nodes that I have to add in. This actually happens with customers where we get the thing was already built by Dell, or the hardware was built by Dell, and then they go, okay, here's all the stuff, here's all the connections, and this is what the customer has required for the node names, and we'll just feed that into Werewolf through like a script or something. Super easy to do. Right, just parses all the logs, grabs all the scripts, generates all these on the fly. Super easy to do. Push it out, boot up all the nodes, and they just come up and connect to the cluster. We're going to get to the boot up process here in a second, but we can directly connect and interact with YAML configs. All right, we can import and customize images. So I can either just download stuff directly from Werewolf, right, like a Rocky 9.3 or Rocky 9.5 image. I think they're up to 9.6 now even. They also have 10. I was looking at that earlier. They had the Rocky 10 images up. And so Rocky 10 is out. We could start testing that in the home lab if we wanted. And we would pull an image down. We would build it and customize it in any way we wanted and push it up to a local repository. And then we would save that as a tar file, and then we would import it into Werewolf. Super easy workflow. This workflow could very easily be automated once we were ready through like CI/CD pipeline. We could probably even shorten this up with like some Packer tools or something like that. If you guys have ever used HashiCorp Packer, it's pretty good. And then we can further customize and harden the boxes and those kind of things, right? So we can do manual builds of these, or we can pipeline, which is very effective for CI/CD type stuff and tagging and that kind of stuff. So we can import and customize images. And then we can go and edit those directly through a chroot jail. I know people call that chroot too. I think that's silly as well. But I just call it chroot, which is because it stands for change root, right? So we can change root jail, and I can go into the Automation Rocky 9 server as a chroot environment, and I can just touch a temp file. Then I can boot that node, and that will have it in that test file will be in there. In fact, I think it's still in there from our test when we were building it. Let's go right here. Pretty sure it's still in there. Yeah, test file. I didn't put anything in it. Yeah, I didn't put anything in it, but I just built it to kind of mess with it. All right, let's get this out of the way. So then we, so then now we have the ability to do this and then modify our base images. I advise when you do this that you stamp them in some type of way to let people know that you've changed them, and then prune off old images if they're no longer being used. One of the nice things about Werewolf is it does keep track of this. So you see here how an image Hammer Linux 9 is assigned to the Hammer 1 node. If I were to go down here and try to prune out an old image that I didn't think was being used anymore, but it was being used somewhere, Werewolf wouldn't let me do it. I actually like that about it. chmod and chown. Chmod and chown. Yeah, that's fine. I'm fine with that. Yeah. So then we can edit the image. So we kind of covered image management, image manipulation. We can look at that a little bit if you guys want to do that live. That's not a big deal. I do it all the time on stream, especially on maintenance nights, which are Sunday nights. We build and define nodes. This is the list of all of Rocky 5. This is all the variables and all the things that are known by Werewolf about the system. And I often think of this. This is very nice because I want to show you guys something about nodes. See how a bunch of these say default right here? When you populate a node in Werewolf, if we go back up here, here's node profiles, and here's a bunch of defaults all the way down to the bottom here, where then you get to nodes. So nodes is like off the bottom here. And then here's your like Hammer 1 node right here. And Hammer 1 node, this isn't all I know about it because all these other things are defaults to it. Now I can override defaults in a node if I want to. So profile here is default. So I'm getting the node profile of default. But I can override like kernel arguments on this node individually if I needed to for testing or something. So it's an interesting thing to kind of know and work with, right? I can't give you all the use cases right now, but what I can tell you is most of this is default node, and some of these things can be overridden or are applied directly to individual nodes as needed. So like in this case, the NetDevs device ETH0, I could have made that a default, ETH0 across all systems, but maybe I didn't want to do that for all node profiles because maybe I'm going to use some SLES boxes and they have some different type of Ethernet by default. Could I change that in the overlay? Absolutely. Guys, this is one of these things, man. Just because you've ever been in a kitchen doesn't mean you know what you're going to be doing that night, right? Like, we're cooking Mexican food tonight, then we're doing Greek, then we're doing Mediterranean. I know those are very similar, but the point is, like, you have all these different customizations and all these different ways to do it. All right, so building and defining nodes, there's an interesting thing that happens here as well, where we can see our runtime overlays. Again, those are updated in runtime of the server as it's running. And then system overlay is things that are one shot at the beginning. The runtime overlay only continues to work if if one of the servers is running the WW client service on it. WW client service makes it check back in. If you turn that off for any reason, maybe you say, hey, I'm going to do this lab and I'm going to turn that off. It does not turn on, by default. You have to, you would have to turn it back on. Or if you reboot the node, since it's stateless, it will come back up with that configured again to be on. So these are the things that we kind of have for our systems. And then we got a bunch of resources down here, and you will notice that these are in JSON format. So we can peel those off and look at those individually, and actually we're going to see how those deploy when we actually get to the templating part here. So all of these variables, all of these values that Werewolf knows about a cluster, we can deploy via templates into these different overlays. I'm going to show you how that works in a second here. In fact, here it is right here. Here's our node, Rocky 5. Here's all this information about him. And when we go look at the overlays that we can build, these overlays can have files and different parts of the files of the file system that are only created as you kind of overlay this. Look what happens here. There's an etcfs tab, and the etcfs tab looks like this when we render it for Auto 5. So when etcfs tab, which is a common place in Linux systems where we define file system entries, right? All of our file systems that are going to be mounted. This is what it looks like. This is what it looks like generated and rendered by the system. Hey, thanks for that, Prime, on Control Byte.
Hello, sending grounds.
You could use that anywhere, and you chose to use it here, so I appreciate that. I just want to show you guys, so this is all the data that we know about the system, and this is what it looks like rendered. But in the next slide, I'm going to show you what that template looks like. And I always think of templates in my head as like those little Mad Libs or Ad Libs from when you were a kid, and your friend would ask you, give me a name of a boy, give me a name of a girl, give me this, give me whatever, right? Like, do these things or whatever. Shalzen, hopefully this stuff's useful to you. I appreciate that Prime subscription. Again, you could use those anywhere, but you chose to use it here, so I do appreciate that. Sending, it's going well. We're hanging out. I had the guys vote earlier, and one person voted to go for this, and nobody voted to not do this, so I'm doing the werewolf talk. And if you've only been here a few minutes, Sending Grounds, you've missed all the other things, but I can tell you that there are quite a few AI-generated images in here. But now that we're in the technical part, I haven't had one for a while. But real quick, guys, just follow along with me. We've got a node definition. This is the node. We're going to have to build some node definitions for those things that some of you guys just saw me build these in Ansible a little while ago, these nodes. In fact, it's right here. We ran Ansible to deploy these in my environment. Our Ansible worked, right? All our Ansible did was this. Target environment was defined. I mean, you guys saw me just do some copy and pastes. Here's our target nodes. Look, I even left the BS at the bottom that wasn't going to be read. Look at it. They're simple YAML. Nodes are target 1-1, 1-2, all the way through 5.2, right? The host is just the host that's going to be hosting them, which is over there. And then the deployer, guys, this is like, I don't want to say this is like simple in that like I'm trying to trivialize it. What I'm telling you is this is simple in that once you see it done once you steal this from me and go run it in an environment, you'd go, that's all it was? That was it? That's it? You guys just saw, I'm not casting spells over here. Like, these are my hands. I'm hitting, you guys are watching me do this stuff. The people that were here for it saw me come in here and look at this and go, okay, what is my target deployer gonna do? Here's what it's doing. Sending Grounds, thanks for giving a gift to the community. It looks like you got Prawn Star. So Prawn Star definitely didn't fat finger his name. But real quick here, look, what does this deployer do? It says on this machine, so I'm going to do something from this machine. And here's some variable files. I'm going to call in Vault. Vault is going to have the username and password, the things that we can't see. We don't want to leave those unencrypted, so those are encrypted at the minimum AES 256 standard. We can go look at that if we want. But then the item node host is going to be this node host. By the way, item is a way that we used to say at the bottom of an Ansible playbook. So our control structures in Ansible used to be with _ items. But now, in the more modern way, it's a loop. But item is always the like counting variable. If you want to think of like the $_ from Perl, or you want to think of the whatever your counting thing is as you count through a loop, right? It's always item. So in this case, loop and then nodes. I looped nodes. Nodes was unraveled from this right here. So the item is each time it steps through, it's going to be node.name, node.host, or node.max. So node.host, item.node.host is right here, meaning put them on this host in Scott's environment, which in our environment was 192.168 11.202, right? So we're pointing it at an XCPNG server, which is right here. This guy who got all of them, if I go to him and I go to his networking, 192.168 11.202. That's how I found him. I went and looked at him there. So again, guys, I tell you, everything I do is chutes and ladders. This thing points to that thing, that points over to that thing. Sending ground, you said that's the best rando sub you got. Yeah, that was one character off. Well, two characters off because the O is a 0. But yeah, that's funny. All right, item node.name. So his name gets populated right here. Test 1-1, test 1-2. Right, that's the node.name. And then the MAC. The MAC gets done right at the bottom here so that we have a unique MAC address even though we're populating the rest of the MAC address. MAC addresses, remember, they're hexadecimals, so they are the numerals 0 through F. And people say, those aren't numerals. They are numerals when we're talking hexadecimal, because hexadecimal can represent 16 states of nature, 0 through F. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That's actually really funny that my thing tried to... I love, like, my closed captioning is, like, super janky, but it's really funny. To me, anyways. And then we loop over nodes, and then loop control extended true. Guys, there is a tremendous amount of loop control that you can do now. With our old with items, you didn't have a lot of control on what the loop was doing. But if you say, well, Scott, could you show me some of that stuff? Yeah, it ends up being just like this. You go over here, you say Ansible loop control, and loops, again, used to be with _ items, so you will still see those in the wild. But now everything is in loop. And then loop has at the bottom of it, so you're doing loop and you just loop over items if you want individually, but we're not going into Ansible too deep now. We're going to be doing that heavily in the automation course. But down here you have loop control. You can label things. I'll be honest, I don't even know all the loop stuff. There's a tremendous amount of control that was added. Oh, we're still on the rotator. Breaking out of a loop, tracking through a loop. I'm going to just link this to people that want it because there's so much, like, you really have to, it's one of those things where you kind of have to do what I call like a Google Safari or a DuckDuckGo Safari. You got to go spend some time with it yourself, kind of. But look, if you have questions about that stuff, drop it in the Discord, because we have a lot of people down the Discord that do a fair amount with Ansible. I'm one of them, but I don't think I'd be in the top 10 in our server for people that do that stuff professionally. I tell you guys all the time, I excel at the basics, but I show people stuff all the time, and then they come back to me like 2 weeks later, and they're like, Scott, what do you think of this? And I'm like, oh, that's really good. And then I go to myself and I'm like, that's way better than anything I've ever done. But I can't let them know that. No, I'm just kidding. But it is true. Like, I constantly have engineers that excel past me, but I do the basics well. So people are always like, Scott knows what's going on. I'm like, Scott has no idea. Trust me, Scott's speaking in the third person. Scott's in a total panic right now. My wife's over there laughing at me. But anyway, so watch this real quick. Again, chutes and ladders, guys. Everything, and ad libs, right? Like ad libs from when you were a kid and you were like playing around with your friends. Watch this. Here's all the things we know about a server. Here's how it's rendered. But now let's take a step and look at there's a piece between this. And when that piece slides in place, you're going to go, that's it? That's stupid. That's easy. Watch this. So here's all the things we know, scrunched down as I see now. And over here, here's what the overlay for fstab-a looks like. It has Etsy and Etsy fstab.ww. That's the werewolf template. And this is all of this gobbledygook right here. Says if.filesystems unwrap this stuff. Unwrap all this. So there's 4 mounts in here that are defined. Home, opt, labs, and lab_work. So there's 4 wrapped up in this JSON in a very hard to read way. Don't try to parse this in your head. Here's what the template looks like. By the way, this came with Werewolf. I didn't write this by hand the other day while I was sitting here sipping on my water or anything. No, this came with it. But what's rendered down into the actual system in the running config is these values, right? So again, well, this is the net effect. This is the running config. Here's the overlay template. And here's what it looks like. This was, maybe I should change this flow a little bit, because this is what it looks like rendered in Etsy FSTab for that node, Auto5. And then over here, when Auto5 is live, this is what it looks like in a live system. Maybe I need to fix that flow, because I really should show this template up here. But anyways, my point is, as we build and customize overlays, it's important to know all that data that we have is available for you to use and render down onto the system if you know how to read it out and do it here. Let me show you a live example that may make this kind of stick for you a little bit. Let's go back to Werewolf. And on a Werewolf node, let's do wwctl list overlays. And, oh God, this is late. It's late for me, guys. Last night I had to go into the college and there was like a dust storm coming, so the students asked to leave a little early, and I was like, oh, okay, we'll leave a little early. But I still talked to them for 2 hours. When I got done, I looked down and I realized I had not hit the record button. So the students that have missed the class that are going to come over the weekend, because we're kind of like an on-live modality, so it's online and live in the classroom. Actually, it's live in the classroom here in Phoenix and up in Henderson, Nevada? Yeah, Nevada. So I had students in 2 locations, but on the same time zone, which was nice. And where I'm going with that is, I hadn't hit record. So then tonight after I worked, I did like an 1.5 hour recording of that class from last night, so that my students that go in on Saturday or Sunday don't come in and see, like I sent an email today that said, hey, all the recordings are up. The first recording is not up because Scott did not hit the record button. Thankfully, this automatically records, so this doesn't really matter. Oh, anyways, overlays list. I'm just saying it's a long day. That's why I can't type overlay list. Good gosh. Okay, here's all my overlays. Now, the overlay that I think is super important or interesting here is ifconfig. Why is ifconfig interesting? Because look, wwctl node list -a for Rocky. Let's go Rocky 5. Here's Rocky 5's networking information. So let's see if we can find these values in the template config for how ifconfig is populated. If you've ever done anything with Red Hat, anything with Rocky or CentOS or any of these types of systems, you know, I know you guys know this, that Etsy sysconfig networking -scripts is where all of our, I know it's super annoying, right? You got to know that. That's where all your networking happens. And then it's in these ifconfig files. Well, we can go and we can populate these files here. Yadav over on YouTube, how's it going? We are just playing with Werewolf. I'm showing you guys a little around how I use it in the home lab. The Prolog lab has had as many as 50 servers facing out for people. We have about 70 servers running at any given time in the Prolog lab. But currently we have 15 because we're not at any kind of scale and we don't really have a lot of use right now. But later on this month, I will pump up the different nodes that need to be pumped up as I watch the usage and see where we need to go. Maybe eventually we'll make that automated in some way. But for right now, we build them out a little by hand. But it is good for people to see how this works. Anyway, so watch this real quick. We've got a node. We can see right here in the system overlay that he has the ifconfig overlay applied to him. It's a single shot only when the server first comes up. It's not a runtime overlay. It's only a single shot. So let's go look at that. We're going to say wwctl overlay list if config -a. And it's going to show us that if config will overlay these files. Now, I just said etc sysconfig network -scripts, right? That's like one that all of us that have worked in Red Hat for years know. It's always down there, right? And here's our if config -www. Oh, I can actually show you guys one that I had to add. I had to add these because if you guys recall when I was rebuilding the environment, I didn't have the route out of our environment. These nodes, you could connect to them, but you couldn't leave the network with them. So I had to add this route so you could get out of the lab. You could jump into them, you could do stuff, but you couldn't ping out or do any of that. The node itself was kind of locked down. Well, anyways, let's go look at this real quick. So we're gonna do overlay list if config if config. We're gonna switch overlay show. Sorry, we can do cat, and let's cat out this one right here. And now we're gonna go look at the adlib, if we want to think of it like an adlib or a madlib. This is how we are gonna generate an if config file. Now, at first pass, you might look at that and go, well, that's a lot of something. What I would do, what I would posit to you guys before I said, hey, go make sure that's right. What if we had a command? What if we could do the same thing, and then we could say render equals Rocky 5. And what if I could render that file down and compare that to, right? So instead of us sitting around and guessing if that file was good or if those configurations that I had were bad, I could know that this was going to be the rendered file right here. That's the rendering of that file right here. This is the configured by Werewolf. That's it. Does that match with the variables that I think it should be right here? Yes. So if it's good on one, it's probably good on all, but we could, if we wanted to, go to Rocky 4 and render for Rocky 4 and see that those line up. Yep, I see 54 and I see 54. Boom, boom. But there was this other one. There was also this other one that I could have used right here, and it was route. Right? And route needed to have these values assigned. We could say that we could get to this local. This is a local via, and then we also wanted a default one populated. So we go default, any default traffic that we don't know where to go, 192.168.200.1 is our C router interface that functions as a router in our lab. If you guys haven't been around here for that, that's not a big deal. But C router exists right here, and he sits between VLAN 0. Wait, let me make sure I'm not lying to you. He sits between, where is he at? VLAN 1 and, well, I guess VLAN unassigned. and what would be the default, which is VLAN 0 in most networking. So VLAN 0 and VLAN, but it's not explicitly defined as 0. So that bugs me now that I look at it. But right, because undefined things behave incorrectly, and then you can't figure it out, and you just make noises. You just screech in undefined rage because you can't find what the problem is, but you undefined something, so it's your own damn fault. All right, anyways, that's neither here nor there. You guys will get me off on a tangent. I'm on a tangent already, but I wanted to show you guys that all these things point to something else. It's literally filling out like a template or an ad lib, right? And when you know the tools, it makes rendering those templates and putting them on the server super easy. All right, so here's that. And then here's thinking time, right? This is my question for you guys while I sit here with my arms crossed looking all smug. What's the difference between baking and cooking? Some of you guys actually had this, like we did this talk before. But what's the difference between baking and cooking in an environment? Does anybody know? Why do so many engineers like to brew? How many of you guys ever met an engineer that like brews his own beer or something? I've known a lot. I've probably known in the 30, 40 range of engineers over the years that they like to brew beer. I don't know why. But I do know why. But I mean, I'll tell you guys here. What's the difference between baking and cooking? Baking would be similar to brewing in this context. Anybody know? when you cook, right, when you have like an open pot on a stove or something and you taste it and it's not right, you can add whatever you want to it, right? But baking something is a single one shot time. You have to get all your ingredients right, and then you throw it in the oven and you find out 30 or 40 or however many minutes later whether you did it right or not. And if your stuff is crap, there's no fixing it. There's throwing it away and baking a new thing. So yeah, I would call cooking an art, and I would call baking more of an engineering, because baking is like you have to get it right. You have to get your recipe right. You have to follow the procedure. And it's also, baking is also very analogous in this sense to CI/CD pipelines, because in a CI/CD pipeline, continuous integration, continuous delivery, you have to drop in the right inputs and you have to process through them and get the same outputs every single time. Cooking is not like that. Like, you could throw more salt in it, you could throw more whatever. There's actually a really funny, if you guys ever go back and watch the old show Frasier. Frasier's hilarious because him and his brother are like the smartest idiots you'll ever run into. They buy a restaurant and they're all ruining the sauce because they're like, oh, a little too salty, so they throw in something else. And this just sauce is ruined by the end of the night, because literally every time anybody passes by it, they change it in some way, and it just ends up being really terrible. Try to get an ATO on the pipeline that has unpredictable. Yeah, and any kind of unpredictability is, I would almost call that like, or instability is almost like the enemy of productivity. Not enemy of productivity, that's security. It's the enemy of automation, because unpredictability, if I can't, I often tell you guys when I patch servers and I build servers, I do what I call painting with a wide brush. I want to hit 95 to 97% of those servers good. I know there's going to be, Pareto's rule says I'm going to have a problem with a bunch of servers, right? That's the 80-20 rule. I know I'm going to have problems with stuff, but I want to get as many of them as I can. And then when I'm looking at knocking off like problems that have happened, I try to go with the biggest ones. One that used to always get me on like 30 servers, because I would patch 1,500 servers a night not every night, but in our patching windows, and which would be like once or twice a month, depending on what we were doing. And they would be my Saturday nights, like late into Saturday nights and early Sunday mornings. I'd be patching, and even automated, it still took a lot of time. And one of the big ones that would always get like 30 servers was you weren't able to deploy you had done all your other stuff, your Yum checks came back good, but then when Yum tried to actually put stuff into the system, not just a Yum check that it could hit satellite, that's one thing, you always check that, but another one that I built in was always to check that the RPM database was built properly. Because if I couldn't install something actually to the server because the RPM database wasn't there, I always wanted to rebuild the database. So I would test that I could read from the RPM database. If that failed, I would set a flag. I would set flags. That's like how I learned how to do this. So I'd set a flag, and then that flag would then tell the next thing to, and by the way, you say, why don't you just do the next thing or whatever? Well, I want the flag set because at the end I can resolve all the flags, right? Because I want guys, when I patch, I want everything to finish. And then I go back and I look at what broke myself. I would prefer that over things breaking and falling out. That's just me. But there's different, again, this is one of these things, like, how do you want to do it? But where was I going with that? Yeah, when I would patch, paint with a wide brush, set that, rebuild the RPM database. And that would save me like 30 servers that me and because I'd always have like about 5 or 6 of my junior engineers, and they would be my little gophers to go fix stuff. And I would be like sitting at the big Ansible kind of like Ender doing all the main work, and then they would be hitting all the little stuff that was broken. And typically I had like resolutions for most of the things that could go wrong. And then if something was really bad, I'd go fix it. Or sometimes we had to roll back and just redeploy, right? That happens sometimes. But you want that to be as small as possible, right? Anyway, so the reason I say baking and cooking here is baking would be building the image, and cooking in this context, things that are quick to change, would be your overlays, right? So that's something to think about. So you have to decide if you want to bake your solution into containers, or you can cook with the system and runtime overlays. So runtime overlays are super easy to change. When I'm doing this target stuff and I need to change the targets, maybe even between the weeks, if we have to change the targets, I could just build an overlay and apply it to the servers only during that week. I probably won't do that now that I think about it, though, because I want the replayability of the course even if I'm not around. Like, even if I'm not, like, running the course, I want people to be able to get in there and have the same environment. So I might not do that. If I have any special customizations, we'll probably do it through the GitHub, where people will pull down the GitHub, configure the environment that way. That's something that me and Colchis had been working on in the Rocky servers, because I wanted to extend more. I wanted the environment we already have in the lab book that's already done for the sysadmin course. I want people to be able to go in there and do more stuff and practice more. Some people just need confidence in doing more Linux, right? Some people need confidence in how to interact with the business, and I'm trying to show you guys all that stuff, right? Because it's kind of, the days are gone by where we get to just sit in our little server room like a little mushroom and nobody bugs us, and just make sure that we have, snacky time every now and then, and doesn't know what we do, and just as long as the servers are working, nobody asks us anything. That's gone. PCI compliance, your GRC teams are going to come find you. Your governance, risk, and compliance, they're going to be finding you. People are going to be constantly asking you questions, so you got to know how to deal with this as an engineer, right? All right. So Werewolf boots servers like this. This is one of my favorite ones. Werewolf just pushing the images and system overlays and runtime overlays and kernels, if you use kernels optionally, into the environment. So Werewolf's got them all. And now we're going to talk about how the stateless node boots up and queries DHCP. He doesn't know who he is. He needs to figure it out. Werewolf identifies the server via its MAC address, right? It keeps track of all the MAC addresses. Server starts with a minimum boot kernel and downloads the two components it needs over TFTP, which are the kernel and the init RAM FS. That's that first boot kernel is the Drakut. It's a two-stage boot. And then system pulls the overlays and applies them. And then server start the WW client, and that pulls runtime overlays every 10 minutes or configurable amount of time after that. That's what the server's doing. If you guys have never seen this in the home lab, before I explain it, let me just show you here. Just reboot a server real quick in the environment. And while I sit here and sip on my water, you guys can watch Auto5 reboot. Excuse me. We can ping him over here too for fun. So we're pinging Auto5. His console's going to come up here in a second. And we're just going to watch him boot. Yeah, and Control Byte, I don't know if you or any of these other guys have seen, like, it seems like the whole industry turned the last few days or maybe even a week now on GitHub. People are, like, super worried because, like, the GitHub CEO stepped down or something. Is that right? And I was hearing, I've been seeing all kinds of stuff and seeing it even pop. It's weird when things pop up on LinkedIn. I'm like, I expect this over on, like, X or something like that. But watch this node. He's already found out who he is. He's Auto5 because the server told him. But now he's going to boot up. It's going to take about 180, maybe a little less than 180 pings, so about 180 seconds. Now you see him starting his two-stage Drakut. He's going to go and he's going to download his init RAM FS. That's the first download, and the kernel. And then he's going to boot up. He's going to start his system overlay. We're going to see some warnings. It's not that big of a deal. Yeah. But have you guys heard about this? There's time to get the cert for all the jobs. Yeah, but have you guys been hearing about this? I've been hearing people just talking about, like, jumping ship from GitHub, like getting out of there, and they're like, what are we going to use next? And I'm like, go back to SourceForge. Just funny. You haven't heard of that, King Buns? Yeah, you probably deal with that more than I do, but I've just been hearing people talk about it. I guess somebody, I thought it was the CEO, had stepped down. Look, we're going to get some warnings because I have older hardware. You're going to get that when you're building out a lab on the cheapest budget that your wife will allow. I had to do that so she would turn and look at me. No, she's authorized me to get the NVIDIA Digit server, which I think they've already changed the name on, even though they haven't released it yet. As soon as this starts pinging, you're going to see this come up over here as finished. The overlay is applied right at the end, right before the server comes up to finish its startup. The last thing, and we could do a blame, right? Systemd analyze blame. The last thing to finish is always WW client. I'll show you here in a second. Watch. He's about to be finished over here. When he finishes over here and comes to a prompt, you'll see the ping there, right? See? Almost almost exactly right there, almost exactly within 5 seconds. And the reason for that, for people that care, right? If you're like, Scott, can you show me? Yeah, right here. If we do system D, analyze, blame. This is one of my favorite commands in all the world. System D, analyze, blame. Look who took the longest to come up. You should be ashamed. So these are, I need to emphasize, these are chronological. I literally said the exact opposite thing I wanted to say out of my head. Like I'm having major brain problems over here. They are not chronological order. They are in the length of time it took to come up. And they are not serial. Serial would be one after another, right? Like I'm not a serial killer. I kill in parallel. Like I kill 2 people at a time. Well, these are running in parallel. And you might say, well, how would you know that? Well, because these right here do not add up to the total start time of the system. The total start time of the system, if you just do system D analyze, it'll tell you that startup finished in 44.762 seconds for the kernel, and graphical target was reached after 8.789 seconds of user space. Also, I'm really surprised it's going to graphical target, but I'll play with that later. The longest thing was the WW client service right here. That's also longer than I thought it took, but that's fine. We're in a home lab, or we're in a stateless node environment, so we don't really care too much. Let's go break down all that stuff you just saw. You just saw it work, right? But let's break down how that's kind of working. So right here, this is the node boot process. So a node boots, and he wakes up on the network, and he doesn't have intrinsic to himself or in his configuration. Well, okay. If we step back a second for general hardware, a system does a power on self test. That's not necessarily required for a VM, but VMs still go through that, right? They have a power on self test of some type. And at some point, the boot up process takes over and it starts to look for, if it's disks first, it'll go look for master boot records on one of the disks. If it doesn't find them there, it'll fail to next one. I have it set, I'm pretty sure, for networking to go first. So we don't see those failures, but the system reaches out over the network by broadcasting all Fs. There's 48 bits in a hardware address, but when you want to talk to the DHCP server, you broadcast all Fs. So you broadcast, it's 12 Fs, right? Because it's 12 times 4, 48. So it's 12 Fs would be all 48 bits for your MAC address. And you broadcast out, hey, I don't know who I am, right? It's the old BootP protocol for communicating on DHCP. And the server will respond with, hey, little server, I see that you are this address. Now, only Werewolf will do this. A normal DHCP will just, do I got a pool of addresses? Do I have something for you? Take it. That's what a DHCP server will do. Werewolf is a little smarter than that. It'll go and check, and it'll say, hey, you're this Auto 5 server. I know because of your hardware address right here. You've got this image, and you've got this kernel version and these other things. Go ahead and start your iPXE boot with these values here. So 192.168.200.25 Werewolf port 9873 in my environment is provisioning for that server this asset key and this UUID. It's going to give the right information for the Auto 5 server, right? And then that's all these things I just said right here. Server pulled down 2 things from TFTP. Then after it gets this, it'll do its kernel and its init RAM FS. Then its server runs a 2-stage DRAC that I kind of showed you. You can actually make that the default so it doesn't show that little splash screen, but I just left it because I don't really care. Like I don't care if it takes 55 seconds or 50 seconds to boot in this environment. I do care that sometimes at work. Sometimes I have requirements that whole sets of nodes have to be up in under an hour, and in that case I will shave off 5 seconds here and there if I can. Out here, you guys see like the sloppiest version of me by far because I just don't care in my home lab. The server enters the DRAC and it starts to download the other init RAM FS and the kernel. Or you can have other methods. The other methods are found on the Werewolf page, but you can boot over. You can use grub boot, but I don't have grub in those images. You have to add the grub to the images if you want to do that. There's also a HTTP boot, which I don't really use that either, so I don't really know what that. I don't know anything about that. I use the iPixie version of the boot. So there's other way. Anyways, the point is, especially if you have requirements in your environment, like maybe somebody's like iPixie is an old protocol, we can't use it. We have a requirement. I'm telling you, ISSOs get weird, just weird hairs up their ass as far as that goes, right? Like they'll just say weird stuff and they'll be like, iPixie's 20 years old. Somebody's compromised that, and you're like, oh my god, dude. If somebody's like sitting on our network watching our DHCP traffic, we are already on the news, right? Like we're already done. But anyway, but okay, fair enough. Use something new, whatever. But all right, so node boot process. The next thing are the system overlays are applied. So here we saw that Werewolf was doing maybe loopback. We maybe pushed out some different things. I got some broken stuff in there, and that's fine. Bringing up its interfaces, and then there's just these different things that are starting in the environment. We can change those, the order. So if I needed SE Linux to come up first, I could have that. Now I have SE Linux turned off, so I don't actually care that there's this error here. But because I don't have this targeted policy there, it's never going to start SE Linux. I could put that in via an overlay, and then it would work just fine. So there's like all these things that we could do. I used to run SE Linux on the old version of Werewolf in the lab, but we don't run it anymore because it doesn't really matter. And then kernel will mount root. So what will happen is once you have the kernel boot, and it's all done within initramfs, it does a switch root where normally it will switch root to a hard disk, like a whatever is configured in etcfs tab to be the root mounted thing. In our case, we use tempfs, so we do everything in memory. We're hardcore all memory in the lab environment, and these are completely what we call, well, it's completely volatile memory, right? Like if it dies, it's gone. There's no persistence to any of this on the system. The only persistent thing that you can have is lab work, opt, and labs. These are where you can save things in our environment if you needed to, and those are backed up. So even if somebody goes and deletes something, like I know Zorgel's got stuff out there, if people were to deploy those things and or delete his stuff, we have backups, right? We have a little backup script that runs every night. So time to buy 100 Raspberry Pis. King Buns, I used to run on the Raspberry Pis. The thing that was before Werewolf was Beowulf. Same guys ran Beowulf. And I used to run that on my clusters. Right? I used to have a bunch of Pis on those. But. All right. Productionalizing Werewolf, right? So Werewolf's ready. Put me in, coach. I'm ready to play. I think those are so funny. But he's like, put me in, coach. I'm ready to play. Well, we can have high availability Werewolf. Earlier, I described Werewolf as a service running on a machine that was installed via an RPM. So what we could do is we could use CoroSync and Heartbeat, very common tools. In fact, I need to build some labs for them in Killer Coda. And CoroSync will assign an IP address to an interface only when he's primary. So we could have a primary Werewolf virtual IP in our environment of 172.16.05. Let's just say that's it. And then Werewolf Management 1 is 172.16.06, so he's his own IP address. And 172.16.07 is also his own, but nobody in the cluster ever talks to either of these. They only talk to this virtual IP, this VIP. This VIP is then highly available because he will have it, and if he is ever not responding over Heartbeat, the backup secondary will take it. If he is ever not responding over Heartbeat and the backup secondary goes to turn on and can't reach him, he will kick him over. He will do what's called stoneth, shoot the other node in the head, and turn him off over his IPMI link. We can do that. That's been around a long time, right? He'll take all the resources. So the resources that are on in CoroSync would be like the Werewolf service and maybe the mounted disks of the configuration, the shared configuration. What you saw in my environment in Etsy Werewolf would be shared down here. All the Werewolf components can be on direct attached storage. And as CoroSync comes up over here, he'll start the logical volume manager and only attach the disks if he needs to. And then he'll turn on the Werewolf service only if he needs to. And he'll only listen on port or IP address 172.16.05 as the virtual IP if he needs to. And he will kill this node out of the environment. This is a very big one. This is actually one that my company got asked by CIQ to train people on this because this is something that we do so well for big government customers. This component right here. So one of my colleagues, Kyle, was the one who wrote all of the CoroSync stuff for this. And there's other things that we actually fail over as well. We fail over the because we use the cluster manager for the ISO management as a repository too. So he's the repository server, right? Anyways, that's high availability. And then review, like, what do we do around here? We build servers, we work on servers, we do Linuxy things, and we use Werewolf because Werewolf fits into the stateless environment, just turning nodes off and bringing them back up in a clean fashion over and over again. What are supercomputers or HPC systems? They are a standard type of just typically research and big job running. I guess I can't use cluster in the name, but they are a set of servers that are defined by NIST 800-223 in a way that allows for workflow to be dropped as jobs and run across, a vast number of servers, right? What does Werewolf do? Werewolf maintains the resource management and the deployment components of that big cluster. How does it do it? Well, we talked about the concepts and the workflows. If we talk real quick, for people who got here a little later, this is what it looks like in a high performance compute system, right? There's the NIST standard if you want to go get it. You come in through login nodes, you transfer data in and out through your data transfer nodes. You've got a web portal node if you have specialized services that people can attach to. A lot of times this will be like an open on-demand server doing Jupyter Notebook, RStudio, and maybe, Jupyter Notebook, RStudio, and what's the other one people use a lot? MATLAB, right? MATLAB, and then they can send jobs in, and the scheduler, something like Slurm, typically will apply those resources to the cluster and then give them back to the web portal, and then you can do your Jupyter Notebook jobs or whatever against your cluster. That's kind of a more modern way of doing it. We used to just have everybody get in on command line and kick off their jobs that way, but everybody wants web portals and everybody wants everything accessible. Open On Demand is an excellent tool for getting that stuff. I'm going to set that up in the home lab eventually and give people, like when we start doing some of our research stuff and people want to come in and play with research data on the cluster, it'll be a lot slower than a high performance compute environment, but it'll be the one that we had, right? It'll be like when people complain about anything, that's the only one we got, right? So, all right. Anyways, that's all of our talk there. I probably should be done with that because it's getting late, but that's how Werewolf fits into the company. That's how we use it around here, right? And pretty good little tool. It's very convenient once you get. There's a little bit of a steep ramp up learning curve of some of these commands and stuff. Also, some of you probably got here a little late. I think King Buns got here a little late. You missed. I was deploying my home lab environment with Ansible, so I deployed all of these nodes a little while ago. All of these guys, all the target nodes, I deployed them all with Ansible a little while ago. Simple little playbook that I wrote a long time ago. Actually, me and Michael Pessa went in and fixed that because there was a problem with the module. And it's kind of funny. I was thinking about it. I'm like, shouldn't I probably push that back up to Git? Nah, whatever. I don't work on it enough for that to matter. Plus, I don't think anybody's supporting it. And one of the worst things I could do is do something like that and then be the guy who ends up having to maintain it. That would be the worst thing. All right. Guys, here's what we're going to do. I'm going to call it here. I appreciate you guys all coming. I will not be on tomorrow because tomorrow night we're watching. Some of my friends are fighting. Actually, I know two people that are fighting tomorrow on Amazon Prime. They'll be in the what's the Amazon? It's the Amazon Fight League. The one championship. Yeah. Oh, hold on a second. Natalie's not on the front page. Two different people that I've trained with are on here. Trained with in the last few months too. Yeah, it starts tomorrow. Yeah, tomorrow at 6 p.m. So it's included with Prime. Does this actually drop me into my Amazon Prime? Okay. Does it show everybody in here? surprised they don't have all the. You'd think they'd show all the fighters that are coming up. One championship. Let's see if they've got the card for tomorrow. And it's over in Bangkok, by the way, too. I just want to see the lineup. Where's Natalie at? That's interesting. Is this the one that's early that they were talking about? 5:30. Yeah. Okay. Sorry. I'm like, wait a minute. Where are the two people I know? So it's Natalie Ty Rutolo. I trained with him. He's actually his brother's an ADCC champion, but I trained with him earlier this year. And then Natalie Salcedo, which is funny. I swear they're photoshopping her to look more angry, but these are two people I've trained with recently. I know Natalie and Ben very well. I've been training with them since 2017. I go to their camps down in Mexico and that kind of stuff. But yeah. Anyways, they're fighting. So we're gonna be watching that tomorrow. Me and some of the guys are gonna be watching that at my house. It's free on if you got Prime. So we're gonna be doing that. They've been over there for a few days in Bangkok now. Tonight was weigh-in. So yeah. Argentina. I don't think that girl knows what's in for her because Natalie. First off, she's 3-0 as a pro, and all of them I think are sub finishes, and she's also a black belt world champion in Brazilian Jiu-Jitsu no-gi. So that's like one of the number one things that you would want to have if you were going to be fighting against, well, probably anybody, but definitely she's been able to capitalize really well, and her subs are always something to do with triangles typically, so it's pretty good. What else we have? All right, so that's why I can't be on tomorrow. And then Saturday night I can't be there because I'm going to a baby shower for one of our ProLug group members. In fact, so one of our guys is having a baby, so I'm going down to Tucson, which is about 2.5 hours away, and we're gonna go. Me and the wife got invited to the baby shower. Trust me, I've known him longer than, well, not longer than I've been running ProLug, but I've known him since he started Linux. So I gotta go to that one. But that's it. Okay, then let's call this at. This will be our end of session. I appreciate everybody coming. I will see some of you guys later on. Make sure you guys hop in the Discord if you want. The Discord is free. There's a Discord link for people on the Twitch side. Hopefully that stuff's kind of useful to you. And if it's not super useful to you, well, I mean, I guess there's a bunch of other people teaching Linux and stuff too. So find them and get into this somewhere, even if it's not with me. And I will talk to you guys later. Take care.